Perfect. So Oscar, I do a little bit of work with this tool DBT, and Oscar asked me to give an introduction to it. So I'm going to do my best. First of all, I'll just tell you a little bit about me. My name's David Kane. I've got a background in psychology and neuroscience, which I worked in for 10 years. And 3 years ago, I came back to the UK and started a career in data science and data engineering. In that time, I also had a baby. That's young Penny Kane up there, and we've been renovating a house. So I'm working freelance now, and my work is primarily around BigQuery and associated products in the Google Cloud Platform. And I've got just 2 clients at the moment. One's Official China, where we're building a database of Chinese newspapers over the last 30 years. And primarily what we're doing with this database is we're doing near copy matching of the newspaper articles. Because it turns out in China, there's no such thing as plagiarism. So they just copy all the articles. So if you want to find out trends in China, what you do is you just do near copy matching of articles, and you see which articles are popular over the years and over the days. And the second client I've got at the moment is Pitch Drive. And Pitch Drive is a website where people, they fill in an online application if they've got a startup and they're after some venture capital, they're after some funding. So we're building a database of these applications with the hopeful long-term goal of developing the science behind successful startups. There's some interesting academic papers out there looking at how you can predict whether a startup will be successful based on the founders and the market situation. So this is a long-term project where we're building a database to do hopefully some high quality science and data science. So when I was developing this talk, I did a bit of research. I use DBT, but I don't use DBT excessively. So I'm just going to share some of the references that I used because they were very useful. So what exactly is DBT is a great blog that very concisely tells you what DBT is, and I've mostly copied it in this talk. There's Learn DBT, which is a free course on the fundamentals of DBT. The DBT tutorial by Carly Kaufman of Fishtime Analytics, which is great for a couple of reasons. She very succinctly talks about the properties of DBT, but she also talks about her background and why she learned DBT in a particular company. And I think that's interesting to anybody that wants to use this tool. There's a DBT Slack channel as well. So if you're actually going to use DBT, get it working on your computer, DBT Slack channel is a wonderful community. They're very helpful. People answer your questions, and no question is too stupid. For some more in-depth overviews, there's a couple of podcasts there. So if you want to delve into this in further depth, here are all of my references. I realize, having presented these references, that I haven't actually said what DBT is to many people, so this might be very confusing. But here we go. What exactly is DBT? So DBT is a compiler and a runner, and it integrates with modern data warehouses like BigQuery and Snowflake and Redshift and probably others. It's a command line tool, and basically, rather than writing SQL directly in a warehouse like BigQuery, what you do is you'd have a series of files working locally on your computer that are written in a mixture of Ginger, which is a scripting language, and SQL. So the reason Ginger's there is to give your SQL some extra power. It's to overcome some of the limitations of just writing plain SQL, and it gives you a number of benefits that I'll talk about. And how you use this is you type in DBT run into the command line. And what that will do is it will compile your code, and it will run the compiled code in the data warehouse that you've configured it to work with. And the compiled code is just straight SQL, right? So it's just straight SQL that can work in your data warehouse. So in a way, DBT doesn't do anything that you can't do in your data warehouse. It's limited by what your data warehouse can do. But it's sort of a development environment that can help you build your projects with a bit more rigor. So that's what DBT is. Here's some example code. So on the right-hand side, we have DBT code, which is a mixture of Ginger and SQL. And on the bottom, you have your compiled code. So a couple of things to note here. The curly brackets denote the Ginger code. And the top line of the compiled, of the DBT code tells the system whether you want your code, which is just, in this case, it's just a simple select star statement. So that just means we're selecting all of the data from a particular table. And the top line of this code tells the system whether you want this materialized as a view in BigQuery, or whether you want it materialized as a table, for instance, in BigQuery. Or you could do a more sophisticated option. You could run this as an incremental model. So let's imagine you've got a base table which is 10 terabytes in size. You might not want to run the code on the full data set every time. You might want to run it as an incremental model and just run it on the latest today's data, for example. Or you could set this as an ephemeral model where actually the code that you're writing doesn't actually get materialized in a database, but it gets wrapped up in the next bit of code. The second thing to note about this code is the from statement in your code. Rather than you specifying the full table destination, which is, for instance, your project, followed by your data set, followed by your data location, what you actually do is you reference a previous piece of code you want. So this is referencing step 1. And the reason for doing this, there's a number of reasons for doing this. One of them is that, we'll go to the next slide, by having many files linked together by this reference code, what you do is you can produce a lineage diagram, which tells you the order in which your code is going to be run. So you see on the right-hand side, you have a table which is called fact orders. Well, before the code that generates fact orders is run, all these other tables will be run first in the particular order specified by the references. So this is really nice for a couple of reasons. I'm a freelancer, and occasionally I have to explain what I'm doing to my clients, right? Well, if I have this nice lineage diagram, that makes everything a lot easier, I promise you. If your manager's going, hey, what have you done all day? If you can show them this, it's a hell of a lot better than just showing them some code which doesn't make sense on its own. A second benefit is if you haven't looked at your code in a year, well, this is super helpful for allowing you to sort of remember how your code works. I think an important point to make here is actually this lineage, the point of the references is not just to create this lineage diagram, which is really nice. Actually, when you type in DBT run, it needs to know the order in which all these files need to run. Otherwise, if you run fact orders before you run order payments, it won't have the latest updated data. So that's just part of how you configure DBT to run properly. DBT comes with a bunch of configuration files as well. I'm not going to go into all of them. I'm just going to give you a couple of examples. So here we have the profile.yaml file, and this specifies how you connect to a database. So in this case, it specifies that you're connecting to BigQuery, the warehouse BigQuery. You're authenticating with OAuth. And there's a couple of configurations here, right? There's your dev configuration and your deploy configuration. And the current target is set to dev. So when you type in DBT run, what this is going to do is it's going to build your project and your files in a data set called dev. And this is super useful, right? Because the situation I've been in before is if you're developing your code directly in BigQuery itself, and you make a change, you clean up the data or something, and actually, something goes wrong, where your production code, because you're coding it directly in BigQuery, you know, it's all going to go wrong. So your client's going to come back at you and they're going to go, what the hell's going on? Your revenue's exploded or it's completely disappeared, right? So this gives you the opportunity to switch between a dev and deploy environment. And if we go back a couple of slides and we look at the compiled code here, the from statement, you see it's from your project in Google Cloud Platform or whatever. It's in the dev data set, and the table it's going to build is called step 2, right? Well, if you change that to deploy, everything will go in your deploy data set. So this is just some of the functionality that DBT gives you. There's another configuration file called a schema.yaml. And what this allows you to do is add descriptions to your tables and your columns. For instance, here we have a table that's called orders, and we're going to give it a description called customer orders. It has a column, which is called ID, and this has a description that tells you this is the primary key of the table, right? And in the schema.yaml file, you can also apply tests to the table. So in this case, because we know that the primary key of the table is the ID, we might want to test whether each ID in each row is unique, and we want to check that there's no nulls there. So in this manner, you can build a system such that each time you type in DBT run into the command line, it will run these tests every single time. You know, it's very easy for somebody to go into BigQuery or another data warehouse and check that the IDs are all unique. But the point is, this has a system that allows you to do this every time you run the code, so that errors that occur in your code, either because you recode or because there's a problem with the underlying data set, will get picked up very quickly. That's the sort of idea behind this. So in the schema.yaml, you can apply tests, unique, not null. You could have a list of accepted values, and you can even build your own test as well. So super useful, particularly if you really want a rigorous production level code. Okay, and then another really nice feature, right? If you go into your command line and you type dbt docs generate and dbt docs serve, what it does is it builds this essentially a website for you with all of your documentation in it. So we saw in the previous slide, the schema.yaml thing, you can add a description for your table. Where you see in this figure here, on the left-hand side, you've got all of your files and your folders and your files. You click into facts, subscription, transactions, and look, you've got your description of what the table is, and you've got all your columns listed below, and you can look at the data types and the description for all of for everything. So this can be a single sort of source of truth that your team can access. So what else can you do? I put dynamic SQL, right? So anyone that's coded in SQL, and I am sort of in this talk assuming that people have coded with SQL before. If you're not, I realize this whole talk might not make a whole lot of sense. But one of the issues with SQL, right, it has its advantages and it has its disadvantages. So one of the things you can't do in SQL is you can't do what you might call a dynamic pivot. So a pivot is when you have a table like you have on the left-hand side, and you create a table like you've got on the right-hand side, which is basically just summing the values over the different payment methods in the left-hand side and putting them in different columns, right? This is a pivot. And, you know, Excel can do a pivot, Google Sheets can do a pivot, you can certainly do a pivot in Python, you can do a pivot in R, a dynamic pivot, but in SQL, what you have to do is you have to manually write a line for each sort of element of the pivot you have to do. So for instance, you get something like this, sum only when the payment method equals bank transfer, and save that as the column bank transfer, right? That's how you do that in SQL. And that's good in many ways because it's super clear, right? I mean, that's almost human readable, so that's nice. What's negative about it? Well, a couple of things, right? Imagine if you had 100 of these, you'd have to write 100 lines of code. And second, right, actually, what you'd actually want to do is you'd want a number of columns, which is actually determined by the number of classes in the payment method. whereas this is only ever going to give you 3. You know, it's a hard-coded pivot. So using DBT, it can allow you to do a soft-coded loop. And to do this, you use a couple of functions that the DBT, the people at Fishtown Analytics have built for you. So the first function you'd use is DBT utils, get column values, and that would get all the distinct column values in the payment method column, and then you chuck this into DBT utils pivot, and that will do the pivot for you. Now, the reason I'm talking about this in depth is not necessarily that I want to tell you how to code a pivot exactly. I just want to make the point that this is now dynamic SQL, because the SQL that's going to end up in your warehouse is dependent on the values in your data set rather than your code. So you can begin to do dynamic SQL. And I believe the next talk is going to maybe talk about some more fancy dynamic SQL as well. Anyway, that's the point I wanted to make. Other things you can do, which is super useful, right, is you can import packages. So packages and libraries are something that is pretty standard if you're using R or MATLAB or Python, right? But typically in SQL, if you want to use somebody else's code, you cut and paste it, right? So to be a master of SQL is to be a master of the cut and paste almost. Well, DBT provides facilities for you to use packages. I'm just going to give you a couple of examples, right? So somebody's built a package for Snowplow. So Snowplow is a system that collects events that occur on your website. But what you might want to do is group events into a session. So that's a group of, say, page views that an individual user did, right? You've got to code this up yourself. Well, DBT provides a package. So somebody's done this for you. You can just download that package and you can use that. And hopefully that'll be a little bit more reliable than writing the code yourself. It's going to save you a lot of time. Another one for the data science community, there's a nice package for feature engineering. So you can take your data and you can apply these package to do one-hot encoding, to bin data into K bins or whatever, normalize between 0, 1, and many, many more. So there's packages there which are available for you to use. Hopefully the code is reliable. Okay, so just a quick summary of the benefits. But the first one actually I haven't mentioned, because you've got the code running locally on your computer, you've got a series of files there, you can do source control with a tool like GitHub, right? So I've not mentioned that, but that's just something you can use. Technically, you don't need to do the source control if you're doing DBT on the command line, but you can do that. You've got macros, you've got functions, you've got packages, libraries, you've got inbuilt testing, you've got your production and development environment. So you can do some more dynamic SQL, and you can do your lineage diagrams and documentations. Okay, so I realized that I just jumped in this talk and gave you a technical explanation of DBT. When I wrote this talk originally, I actually did the opposite. I was going to talk about where DBT sits in the greater sort of technology infrastructure. I put it at the end for better or for worse. Where does DBT sit? Well, here's a typical example of how you might use DBT, right? So on the left-hand side, you've got a bunch of data sources. You've got Facebook, you've got AdWords. The Dolphin, I think, is an SQL database. The Elephant, I think, is a Postgres database. I don't know what the Leaf is. You might use a system like Fivetran or Stitch, which is these two symbols that call the data loaders, to pull this data into a data warehouse in a relatively raw format. Okay. So this takes care of extracting the data from your various sources and loading into your data warehouse. You're using a third party to do this, right? You could do that manually, sure. Maybe you're going to use a third party. You've got your raw data in BigQuery or another data warehouse. I only use BigQuery, so if I occasionally say BigQuery, it could be anything else. And then what you do is you'd use DBT to help you write your transformations, to help you clean the data, to build a data model that's going to allow you to, either your analysts to just access the data warehouse to analyze the data, or to send to BI tools. I think that's Mode and Looker, or other data consumers for your data science or what have you. That's where DBT sits. And I think when you're discussing DBT, it's probably helpful to discuss the difference between extract, transform, load, and extract, load, transform. So DBT very much sits in the latter. And I'll just explain what those two things are. So extract, transform, load is when you would extract the data from a source. You then, using a third-party piece of software, you'd transform the data, you'd clean the data. Then you'd load it into your data warehouse for BI tools, analysis, and so on and so forth. The disadvantage with this sort of way of doing things is typically the transformation stage requires some highly paid data engineers to do that for you. They might be using languages which your greater data team don't understand. Whereas if you're doing extract, load, transform, what you're doing is you're taking the data from your source. You're loading the data into a data warehouse in a relatively raw format, right? You're not making any decisions, it's just going in there. And then you perform your transformations. So there's two advantages of this, two main advantages. So accessibility, because you can do this in SQL, and SQL is the lingua franca of the database world. And it also adds a bunch of flexibility, right? And decisions about how you're going to process your data don't need to be made as early as they do with the extract, load, transform. And the point of DBT is to attempt to overcome some of the limitations of performing transformations using an SQL database, because as mentioned before, SQL is limited in various ways, and it doesn't necessarily lend itself to a culture of producing reliable code. So DBT is really, it's a set of tools which are going to try and help you improve your data culture in your SQL database. Why is this happening now? That's a big question. No, I've only been working in this industry for 3 years, really. So I've had to look all this up. But the reason why this is becoming a good paradigm, there's a few developments, really. Over the last 10 years, we've had the rise of sort of zero maintenance cloud databases. So these are sort of serverless bits of software that you can host your data in without having to worry about the server-side technologies. They come with very, very cheap storage. You don't really have to worry, unless you've got many, many terabytes, you don't really have to worry about how much data you've got in there, which is new. Previously in these databases, you did have to worry about how big your data was. These have massive scalable processing power, so you can do lots of transformations in there. You might have to worry about your processing costs if your data is really big. Probably don't have to worry about storage costs. Processing costs you might have to worry about. And ease of ingestion due to tools like Stitch and 5chan. Google Analytics data in Bitcoin now for free. Used to cost you £90,000 per year, allegedly. Now certain tools will put your data in there for free. So it's much easier to get your data in there. Okay, and finally, I just want to talk about data culture and what can go wrong with data culture. So this is a situation which I've been in, and you've got a bunch of data sources, and you've got some analysts looking at the data, right? And you've got some managers that are making demands of you when you're looking at your data. And everything's a mess, right? There's no documentation in the data's really messy. Your managers, they want results yesterday, right? I love a business cliche. They need results now. There's no coordination between the analysts. So what can happen is you can have one analyst and they're writing their own SQL code, and he'll report how much revenue you get per day to a manager. And another analyst doing the same thing to another, and reporting the results to another manager. And then the managers talk to each other and they go, we've got different results. What's going on, right? That's bad data culture. It's extremely common in many companies. I've been put into a situation in a company where, you know, as a consultant, where people give me a massive CSV with like 1 million rows and 270 columns, right? And they go, give me some analysis, right? And I'm trying to work out how to compute revenue. There's 17 columns for revenue, with tax, without tax, who knows, like some acronyms I don't understand. It's a mess. It's a horrible position to be in. And actually, unfortunately, that's where data analysts can often find themselves in companies. So I think DBT really provides an opportunity to help the analyst in this situation. And this is sort of the data nirvana that can happen. So you've got your data sources, they're going into a data warehouse. You then, using DBT and various suggestions that they have for how you should model your data in your warehouse, and you've got nice clean data, it's really well documented. We've got one analyst rather than two now, because, you know, the chaos has gone. Your managers are really happy because everybody's making money. This is sort of, you know, this feels like a toy example, but I really think there's an opportunity in many companies for data analysts who can see the obvious problems they have in the company to look at DBT and go, okay, DBT provides a solution to this. It provides the technology, and it actually provides a whole bunch of guidance about how to develop a good culture, to develop a good data model, such that this chaos of your data disappears, right? So, you know, DBT is a technical tool, but what it tries to do is promote, I think, a good culture. This is certainly what they talk about in the podcasts in the reference. So that's all. That's DBT. I hope I didn't jump into the technical stuff too quickly and lose everybody. I feel I might have, but let me know if you have any questions.